Okay, so my screen decided to minimize and it shut off my video. So back to a second example before we jump into the really ugly ones. If I want to complete the square here, I still have to mentally separate the 2x squared plus 12x, but I also have to actually separate, and not just mentally, the 2 from the x squared. You have to have a leading coefficient of 1 if you're going to make this work. And if you're going to move that 2 outside the parentheses, you better make sure you divide it out of the 12x as well. So now we go back to the question we had last time, where what do I add to x squared plus 6x to get a perfect square? And we again take whatever number is in front of the x, we cut it in half and get 3, we square it and we get 9. But then we're going to be super careful because to balance this equation, we can't just subtract 9, we actually have to subtract 18, because if we distribute that 2 in, we actually have added 18 and not 9 to the whole thing. So it's going to be a minus 18. So I'm going to end up with 2 times x plus 3 squared minus 20. Okay, so that's kind of my intro. And like I said, go back and work on that 1.1.1 part 3 homework, the complete the square online homework, until you're comfortable with those easier ones, because there's no way you're going to feel good about these until you're comfortable with those. Okay, so we're going to mentally group together the first two. We're going to actually, physically, factor out the 3 to separate it from the x squared. Remember that factoring it out is a division, so we have to also divide the x over 2 by 3. Okay, and I'm going to leave us a little room because here's where we're going to do the magic step. This is the complete the square step. So to complete the square, you're supposed to take whatever number is in front of x, so 1/6 in this case, divide it by 2, and then square it. 1/6 divided by 2 is 1/12, right? Dividing by 2 is the same as multiplying by 1/2, so we're thinking 1/6 times 1/2 is 1/12. When we square that, we get 1 over 144. Okay. If we want to balance this equation, we also need to subtract, but be very careful. You didn't really just add 1 over 144, you added 3 over 144. So you're also going to want to subtract 3 over 144. Okay, so fine. If that wasn't messy enough, now we have to be able to spot, how does this factor? What is the perfect square that I end up with? And that can be a little tricky when these get weird, but what I would say is remember that you're looking for 2 identical factors, so x plus or minus something times x plus or minus the same thing, and we need the product of those things to be 1 over 144, and we need the sum to be 1 over 6, so that's going to have to be that 1/12 that we were using. That's the whole reason that number works. The square of 1/12 is 1 over 144. And if you double 1/12, you do get 1/6. So whatever that number is what you're going to use here. And then I kind of hate myself for this arithmetic. What is 3 times 144? So we get 300, 3 times 100, 3 times 40 is 120, 3 times 4 is 12. So what, 432? 432. So we get 432 over 144, multiply top and bottom by 144, minus 3 over 144, so 429 over 144. Okay, you might want to double check me, but I'm pretty sure I just did that arithmetic right. So these are terrible, but it's just, I'm hoping that you can see that that complete the square algorithm absolutely still works on other messy things. Okay, so let's try it on this one. I actually think this is a little less terrible than the last one. So I'm going to go ahead and mentally group together the 4x to the 4th minus 8x squared. This might not look like a good candidate, but basically on any trinomial that fits that one power is twice as big as the other structure, you should be able to make a perfect square out of that. So it's really like a something squared plus or minus something structure that we're working with. So I'm going to separate out the 4, and I'm going to say that leaves me with x to the 4th minus 2x squared. I still have a plus 6 out at the end. And it doesn't really matter in terms of what do I add to make this work out, that those are x to the 4th and x squareds. It's still the exact same trick. So you're going to take -2 and cut it in half. So I'm going to get -1 and then square it. So I'm adding 1, which means I also need to subtract 1. But, very careful, I actually didn't just add 1. There's a 4 outside the parentheses, so I added 4, which means I need to subtract 4 to keep it balanced. So now the question is just, how does that thing factor? So you would want to do an x squared. I'm going to make that a plus 2 out at the end. And then you need factors of +1 that add up to -2. So there's our perfect square. It's a -1 minus 1. So rather than write the factor twice, you can make it into a x squared minus 1 squared. And then we still have the plus 2 at the end. So we're technically done, but I just want to point out that you could actually factor that out even more if you wanted to for some reason. That x squared minus 1 could be an x plus 1, x minus 1, and then you just have to square both of those factors. So x plus 1 squared times x minus 1 squared. A lot of times when we complete the square, our whole goal is to go from having a variable show up twice to having it only show up once. So I'm not saying that's always a good thing, but I am saying that it's a possibility. It might be good in some situations. Okay, so in that same train of thought, this is a trinomial. The power in the first term is twice as big as the power in the second term. So let's try it. So I'm going to mentally group off the 3 to the 2y and the 3 to the y. And I'm going to say, okay, 3 to the 2y. There's nothing to factor out. What do I need to add to make this work out? I think I will rewrite this one. This is a 3 to the y squared. Minus 2. Okay, so I am supposed to, and it doesn't matter that there's 3 to the y's in there, it's just the coefficient that matters. I'm supposed to take that -8 in the middle and cut it in half, so I get -4, and square it, so I get +16. There's only a 1 out in front, so I do just subtract 16 to keep that balanced. And then again, this is what's hard, and I know you're not used to it, and you still might not feel comfortable at the end of the quarter, but we're going to get more used to it, and then it'll come up again, and you'll get more used to it. So we need to be able to factor, and since that's a 3 to the y squared, I'm going to split up 3 to the y and 3 to the y, and then I need factors of +16 that add up to -8, so that's -4 times -4. You can FOIL it out to check. When we have a repeated factor, the simplest way to write that is to go ahead and just put a second power on it. So that is my most simplified version of the statement. Okay, last but not least, and yes, I am fully aware that this is very challenging and probably pushing you guys a lot. So I mean it when I say we might not feel super confident about this. Even at the end of this quarter, this kind of stuff will come up again. I'm really just trying to expose you to some messy looking stuff so that you can think about applying your tools in other places. So here, I see that same sort of x to the 2/3 can be written as x to the 1/3 squared. So even though this is not quadratic, it has a quadratic structure. We'll say that when we get to some equation types as well, quadratic and structure. So if I want to complete the square on this, I'm going to mentally separate out. I tried not to be too mean. I at least gave you a 1 as your leading coefficient, so you don't have to factor anything out. The x to the 1/3 squared and the x to the 1/3. So I'm going to just separate off the constant, maybe is the easiest way to say that. And now I want to make a perfect square out of this. So I need to take 12 and cut it in half, which will give me 6. And then I square it, which means I need to add 36 to make that a perfect square. If I'm going to add 36, I also need to subtract 36. So I end up with an x to the 1/3, x to the 1/3 sort of split. And then I need factors of 36 that add up to 12. And if I've done my work correctly, that will make two of the same factor, and it does. 6 and 6. Product is 36, sum is 12. So we'll write that as our perfect square, and then we'll say minus 41. Okay, so again, just changing the appearance, and you don't get all the motivation, but really the motivation for the complete the square is almost always that I can think of to rewrite an expression that has the variable showing up more than once in a way where the variable shows up only once. That can be really useful. Okay, thanks for watching. Hopefully that helps. We'll see a little bit more of this kind of messy stuff in 2.4, so you'll get another chance to practice some new problems.